In Chapter 9, we'll look at polar coordinates and we'll look at vectors. And the first 3 to 4 sections deal with polar coordinates and different types of polar graphs. And you can see here in this image, we started out in the Cartesian plane with a sine 6 plus 2, 6x plus 2. I'm going to convert that over to polar, and the polar plane is in concentric circles. And when you kind of squeeze that together or wrap it around, you get some pretty cool pictures. So if you see lots of cool pictures, it's probably on a polar plane or a complex plane. Unfortunately, Cartesian is just not terribly exciting. And they look very complex, but polar is actually pretty easy to work with, and sometimes easier than Cartesian. And so in the section 9.1 and 9.2, we'll look at how to graph some points, how to graph some expressions and some equations, and we're also going to look at how to flip back and forth. So let's start with how to just simply read the polar coordinates and how to graph a point. When you're given a point in the polar plane, it's going to look like an xy, but it's actually an r theta. So this is not x equal to 3 and y equal to 5 pi over 3. It's I have a radius of 3, and it's opening up to an angle that has a measurement of 5 pi over 3. So when I do these, I start with the angle and work my way up to the radius. So if I was going to graph A, I would get my polar plane ready, even though it will look like a Cartesian. I will open up to 5 pi over 3, which is going to be like way down here, since 6 pi over 3 would be a 2 pi. And then once I kind of have that angle opened up the right way, then I'll extend the radius from the origin, and when we're in polar, we call it the pole, out 3 units. So 1, 2, 3, out like this. And then this is how you would graph the point. You would mark the angle and then show the lasso, right? That you're lassoing back to the pole. You can have negative angles. That's not a problem. So if I wanted to do a negative pi over 4, I would just go in reverse to pi over 4 and then 1, 2. And I would have my angle opening up the other way. You can have a 0. That's totally fine. You'll just be laying flat. It will look like that you're just sitting on the x-axis. It'll be 1, 2, 3. But it's polar, so it's an R, and he looks like that. What gets a little sneaky, I think, is the negatives, because we're in circles. We're not on straight lines. So if you think about the number line and you wanted to go to a positive 2, and then I said, no, you know what? Go to negative 2. You would just back up and go the other way. And so you would be equidistant, just in the opposite direction. Well, since we're talking about circles, up, down, left, right gets a little shaky. So what I think about it as is pulling a lever through. I ignore the negative on the R, and this is actually supposed to be a positive pi over 4. So I'm going to graph negative 2 pi over 4. I'm going to go to the pi over 4 like I normally would. And I'm even going to throw the lasso. 1, 2. But I don't want a positive. I don't want to head up. I want to go the other direction. I want the negative. And so I'm going to pull the lever and have it come down this way, right through to the other side. And this black one, that's the angle that you want. So some more neatly drawn pictures, right? 5 pi over 3, extended out 3 units. We had 2 negative pi over 4. Negative angles, not a problem. No angle, not really a problem. Well, not no angle, a 0 angle, that's also fine. But when we draw the negative radius, we'll open up to the angle and then we'll pull the lever through to the other side. And it's the one that gets pulled that's your angle, even though it looks like this in here. Now we can talk about these guys a couple of different directions. So this would be a 2 pi over negative pi over 4. Seems very reasonable. But if I were to draw 2 7 pi over 4, I would land in the same spot. And so if you don't label anything, you're not going to be really sure which one you have. I could also graph 3 pi over 4 with a -2, because 3 pi over 4 would put me here, and then when I pull the lever, I would land back over here. And so I have pulled up from MyLabs Plus a question that will walk you through kind of finding different ways to get to the same spot. I have a -3, negative pi over 6. And I want to identify the graph that is representative of the particular point that we have in here. So if I was going to graph just the original one, the negative pi over 6 with a -3, I would say, well, I know I have to go back to the negative pi over 6, but then when I extend that 3, I'm going to have to pull the lever through. So the lever is actually going to land up over in the second quadrant. So I need to be looking at this one right here, and I'll make it a little bit bigger so that you can see it. So negative pi over 6, extend to 3. It really should be labeled, but they didn't label it. Pull the lever through so that you have the negative. But how could I get to this same exact spot? So I want to land on where the little red looks like an old school pin, right? If you see like your grandmother's pins that they used for sewing, that's what it reminds me of. I want to have a positive radius, but I want to talk about this as a negative angle going the other way. So I still want to keep the negative angle. That's okay. What I don't want is to also have a negative radius. So I need to figure out, how do I back up from here all the way to here? And so a little blast from the past, so you have some geometry. If this is pi over 6 right here, this little piece in here has to also be pi over 6 because it's a vertical angle. And so I now need to figure out how much further do I need to go. Actually, I'll snip it this way. This was pi over 6. I know all of this, of course, is a negative pi. So I need this negative pi plus that negative pi over 6 a little bit more, right? So negative 6 pi over 6, so that way I have a common denominator, plus a negative pi over 6. This angle now to land all the way back here, kind of in one swoop from the 0 or from the -2 pi all the way back without having to flip any kind of switches but still land in that same spot, would be a -7 pi over 6. And I want to keep the positive radius so that way I still land over there. So this will be a 3 because I want a positive. I don't know why I didn't like that. A positive radius of a 3, but I still want to keep that negative angle, so it will be a -7 pi over 6. And so I'll land in the same spot. Now they want to know, okay, I want a negative radius, but I want a positive angle. So I want to land in this spot with a negative radius but a positive angle. I think this is the tricky one, right? So you actually want to land down here again and then have to flip the switch through, right? So if I want a negative radius, wherever I think I'm landing, I'm going to be in the opposite spot. So if I would want my radius to land here before I pull it through, and so if I'm talking about a positive angle all the way around, I want everything but pi over 6. So that would be 11 pi over 6. So that I land here. Right, come all the way around, 11 pi over 6, almost made it. Extend the 3, but oh no, I want a negative, so flip the switch through. So I land at the one on the other side. I think that's probably the trickiest one. Now I want to go another loop around. I want a positive radius, I want a positive angle, but I want it on the second go around from 2 pi to 4 pi. So I'm going to roll back up here. I want to land up here with a positive angle and a positive radius. Let's get a, actually I can just erase this from here. So I want to land on the pin, positive and positive. I come around once, no problem. That's 2 pi. Go a little bit more. Now I want to come up to this. Well, remember, this is pi over 6. If I would have kept going and made it back to that r-axis or x-axis, it would have made life a little bit easier, right? Because that would have been 3 pi. So I'm pi over 6 short of 3 pi. That would be 18 pi. So I'm at 17 pi over 6. So if I said go to 17 pi over 6, you would loop around once, 12 pi over 6, and then 5 more. You would land here, and you want to land on the red. You want the positive radius, so then it would just go ahead and be a 3. So 3, 17 pi over 6. It's a little tricky. You'll probably want to go through that one a couple of times. But once you kind of get used to being able to say, well, am I driving forward or driving backwards, it gets a little bit easier. We're going to look at switching particular coordinates from one plane to the other in the next video, and also look at some cool graphs.